Hi, I'm Matthew Jones, and I'm a solutions architect. Today, we'll see how easy it is to deploy HPC applications from NVIDIA GPU Cloud on a GPU cluster. We'll be demonstrating NAMD, a molecular dynamics simulation platform. If you don't already have an account, sign up at ngc.nvidia.com to pull the application containers. Before we can actually run NAMD, we'll have to establish a remote connection with a high-performance computing resource. This can be accomplished in the usual way with SSH. Once we're connected with our HPC resource, we'll have to use Docker to log in to NGC with the Docker login command. NGC provides instructions on how to do this, and it's pretty simple. Go back to the NGC registry and click Get API Key in the upper right-hand corner. There, you'll be presented with the commands to enter and an option to generate an API key. If you haven't generated the API key before, do so now. Then, run the Docker login command and provide the credentials listed on the screen. Once we've successfully logged in with the Docker login command, we can return to the NGC registry. Clicking NAMD shows us the command to pull the container image. We can copy this command and place it in our remote shell. This will pull the container image to the HPC resource so that we can run it. The registry also contains useful information regarding the use of the container. We'll be running the container interactively, so we'll copy the command in the Running NAMD Interactively section. Once this command has been issued in the remote shell, will be placed inside the container where our present working directory on the host machine is mapped to /work in the container. Examples for NAMD are available in /workspace/examples. Again, the registry contains a lot of useful information, even the commands for running the samples with STMV. All we have to do is copy and paste. Now, we'll have to wait for a short period of time while the simulation spins up. After spin up, the simulation will run and you'll see a lot of output. Upon completion, you'll see a message telling you that you've reached the end of the program. And that's all you have to do to use the NVIDIA GPU Cloud. Let's simulate the dynamics of the satellite tobacco mosaic virus and build a locally rendered visualization of the STMV simultaneously using VMD's interactive molecular dynamics extension. To begin, we'll return to our container and run the nvrun script, which calls a modified version of the STMV simulation we demonstrated before. Once launched, NAMD will begin initializing all 1 million plus atoms. At this stage, we'll have to switch over to VMD. We'll see that the STMV molecule has been rendered by VMD from a PDB file. To confirm that we're actually using GPU resources, I've launched a separate remote shell which is monitoring GPU utilization. We can clearly see 8 distinct NAMD processes. The GPU utilization will periodically spike, then return to 0 as the messages are sent slowly via TCP to our local machine. As you saw, containerized applications from NVIDIA GPU Cloud drastically simplifies deployment, especially on a shared cluster. Furthermore, you always have access to the latest version of the software.